Hello, today's lesson is all about energy stores and energy systems. So to start off with, we need to think about the energy stores that are actually in things. Now, by a store we mean something that contains energy and can transfer it to other stores via an energy pathway. And the stores that we need to know are chemical energy, which is found in food, fuel and batteries. So anything with chemicals in is going to have a chemical energy store. We have a kinetic energy store. This is anything in moving objects. A gravitational potential energy store. Now, because this is due to gravity, it means anything that has height. So the higher something is, the more gravitational potential energy store it has. There is also an elastic potential energy store, and this is in things that can become stretched or compressed. Now, these are called potential stores because the energy is not released until either the elastic is let go of or the object is dropped. We have thermal energy stores, which are sometimes called internal energy stores because all things are hot to some degree. The hotter something is, the more thermal energy there actually is. A magnetic energy store, and that applies to objects in magnetic fields. An electrostatic store, so that would be your electrostatic charges. So this is to do with forces between charged objects. And finally, nuclear stores, which are found in atoms. Now, energy can move between systems, so we need to think about what a system is. Now, a system is a group of objects, or just a single object on its own, that can use energy. And generally speaking, systems are either open or closed. So to give you an example, here is a saucepan that's got some water in it, which is all bubbling away quite happily, and we can see that there is in this saucepan, so underneath it there's a flame. Okay, so there's a thermal energy store here, but that energy can actually exit the saucepan. So this would be an example of an open system. Our energy can be transferred away from the system. If, however, we had a second saucepan, but this time it's got a lid on it, there's my water again, it's all bubbling away, there's the flame underneath. This would be an example of a closed energy system because my energy remains in the saucepan. So in closed systems, energy remains in that system. Okay, best way of dealing with this is if there is a door or a window open, it is an open system. If everything's closed, it's a closed system. Generally, all of our examples will deal with closed systems. Now, because energy can be transferred between systems, we need to think about how that energy can be transferred. So energy transfers are ways in which energy moves through a system. And there are 4 ways that energy is moved. It can be moved by forces, which we call a mechanical movement. It can be moved electrically by an electric current. It can move by heating, so that would be by our thermal processes of either conduction, convection, and it can also be moved by radiation. Okay, this is by electromagnetic waves. So for example, light, UV, X-rays as some examples. When we represent energy transfers, we tend to draw a very simple diagram. So for example, if I had my mobile phone, so this is my system, going into it I would have my chemical energy store. This would be the battery. Energy is transferred in my phone from its chemical energy store by electricity, so this would be my pathway into my mobile phone, and that would actually enable my phone to do processes. So for example, I might end up with some heat from my phone, so the battery gets warm, so I've got a thermal energy store. The pathway there is going to be heating. If my phone is vibrating, I'm going to have a kinetic energy store, and because it's a vibration, that means it's a mechanical transfer. Okay, and I might also actually have sound coming out of my phone. Okay, and sound is an example of particles moving, so that would be my radiation. Sorry, that's going to be a kinetic energy store again. Right, but in this case we're talking of particles, so this would be my radiation pathway. Now, in any energy transfer, work is always done, and when we consider work done in physics, what we actually mean is that there has been an energy transfer. And in our energy transfer, we're generally looking at a A force moving an object through a distance, or an electric charge moving in a circuit. And that means that we can actually define this term work done mathematically. So work done is equivalent to force times distance. But we will come back to that in a later lesson. And the thing to remember here is that work done is always an energy transfer. How much energy has been moved from one place to another. And finally, talking about energy, we need to talk about the idea of conservation of energy. Energy cannot be created. It cannot be destroyed. It can only be transferred from one store to another. So if I go back to the idea of my mobile phone, using this diagram here, if I start off with 100 joules of energy in my chemical energy store, at the end of all of my energy transfers, absolutely all of that 100 joules will be transferred on this side. Obviously not all of it's going to be transferred equally. My phone doesn't vibrate for very long, my phone doesn't get hot for a huge amount of time, okay, and that's why it might take several days for this energy transfer to go, but eventually we will find that the chemical energy store of our battery runs down to zero because all of that energy has been transferred. So this is our conservation of energy. Energy can't be created, can't be destroyed, it can only be transferred from one form to another. However, and there is a however, not all of the energy is transferred usefully. In other words, I might not be able to use it for anything useful afterwards. Okay, all of the energy is transferred, but not all of it will become useful at the end of all of my transfers. If you've got any problems, please don't hesitate to contact me either through the school website or through this website.